so much for joining us today for the second in our 2022 webinar series focused on AIS. And today we are going to be looking at various ways research has been incorporating AIS data to help understand the marine environment in new ways. So our research today is being drawn from all three coasts. We've got one looking at the Pacific, we've got in the Atlantic, and also some work in the Arctic. And I want to acknowledge to start with that I'm currently situated on the ancestral territories of the Cowichan tribes. That's on Vancouver Island. And I'm very grateful for the long stewardship of the lands and waters of this area, and I believe we have a lot to learn from how Indigenous knowledge understands the marine environment in a more holistic way than sometimes what Western science can achieve. Our first speaker today is originally from some of the work was done at UVic, and I'm sure she'll mention that more, but is now with Department of Fisheries and Oceans, and that's Norma Sarasogas. And sorry, I'm distracted by a few more people joining. We'll get everybody in. And just for those who may be new to this webinar series, the Canadian Marine Shipping Risk Forum is a community of practice that was launched back in 2019, and it was an effort between MEOPAR and ClearSeas. And MEOPAR is the Marine Environmental Observation, Prediction and Response Network, and a collection of academics across Canada working together for those purposes, and ClearSeas Center for Responsible Marine Shipping, a nonprofit research institute focused on safer and more sustainable marine shipping. And we had some support from Exact Earth, which is actually now Spire, as they've been bought by a larger company, and they're providers of AIS data from satellites. So the community of practice's purpose is to provide a place, a gathering place for people and organizations who are working in or conducting research on shipping risk. And it allows people the opportunity to network and share knowledge and have conversations about this topic of marine shipping risk, as there is certainly a lot going on in this space. So our agenda today, before we get into speakers, we'll just go through some quick introductions, and then we'll hear from Norma and Andrea about using AIS to learn about commercial whale watching operations. Then we'll go to the Atlantic coast to hear from Leah Fulton about collaborative remediation of abandoned, lost, and discarded fishing gear in Southwest Nova Scotia. We'll have a short break, and then we will hear from Mark Stoddard about example use cases of historical satellite AIS data for the analysis of maritime activity in polar waters. I've allowed some time at the end if there's additional questions beyond what we have time for each of the presentations. And if there are no additional questions, then we will just wrap up a bit early. But I wanted to allow that time, as our first webinar had quite a lot of conversation and questions, and want to make sure that if there are people want to ask questions of the speakers, or if people want to share their own experiences using AIS data, that we have a chance to do that. Okay, so now let's move into our first presentation. With all of these presentations, I'll ask that you just hold your questions till the end of the presentation. We've allowed for time at the end of each presentation for questions for that speaker. And when you'd like to ask a question, feel free to raise your hand, or you can type it into the chat if you prefer, and I'll monitor the chat and read out any questions that come into there. And you're welcome to have your video on if you'd like, or off if you prefer. And we will hope to have an engaging conversation after each of these presentations. And if you have any questions or any technical difficulties, again, please feel free to use the chat or message me directly, and I will do my best to help you out. So our first speaker is Norma Sarasogas, and she is joined by Andrea Nizdoli, and they will be presenting the results of a project that used AIS data to track commercial whale watching vessels in the Salish Sea and west coast of Vancouver Island. And this project was a collaborative effort between the University of Victoria and the Department of Fisheries and Oceans. So Norma is currently an aquatic biologist in the Ocean Science Division at Fisheries and Oceans Canada, and previously she was a research associate with the Coral Group at the University of Victoria. Norma completed a Master of Science in Geography at UVic, and she also has a Bachelor of Science in Biology and Marine Science from the Fairleigh Dickinson University. And I'll just share Andrea's bio as well. They're going to be sharing this presentation. Andrea graduated from the University of Victoria in 2021 with a Master of Science in Geography, and her thesis work focused on modeling marine vessels engaged in wildlife viewing behavior using AIS. And currently, Andrea is a spatial analyst for carbon modeling with the carbon accounting team at the Canadian Forest Service. She has a passion for spatial data science, machine learning, and remote sensing of the environment, and is also fond of ball hockey and volleyball. I will now hand over to Norma and Andrea to share their presentation.
Thank you. I guess I would like to start first by acknowledging and respecting the Locanon people in which traditional territory I live, play, and work, and the Sankis, Esquimalt, and Wasanic peoples whose historical relationships with the land continue to this day. I'm going to share my screen, but I'm also going to share in the chat a link to the story map. So I'm going to be using a story map to walk you through the work that Andrea and I did in the last 4 years now. Yes. So first, let's share the screen, and hopefully you can see it now. So you're welcome to, you should see the link now and click on it and take a look at the story map. You can welcome to follow it on your own or just look at the screen and as I walk you through its content. Depending on your internet connection, some of the maps might take a few minutes to load, a minute or two. So maybe it's just best if you follow along. I might skim quickly through some of its content because I created this with the idea of being viewed independently without the need of having someone presenting. So some of it is quite detailed, so I'm just not going to go in a lot of depth with it. And the story map is going to remain available and open until the end of July this year. Afterwards, I have to close it down, but I'm working on an alternative arrangement so I can we can make the content more permanent or at least for a few more months anyway. So with that, I want to introduce you to the talk today, watching operations in Canada's Pacific region, where we use AIS data to gain insights into commercial whale watching operations in the Salish Sea and the west coast of Vancouver Island. So the aim of the story map was to facilitate communication and exploration of the results. And this work is part of the WAVE project. You have a link here, maybe you want to take a look at it, which was carried at University of Victoria and was funded by MEOPAR and Exact Earth, which now it's Spire. So commercial whale watching operations started in the 1980s in a company based in the north coast of Vancouver Island, but it has grown quite a bit since then, with now an estimated 49 whale watching companies that operate in the Salish Sea, west coast of Vancouver Island, and north coast of Vancouver Island. And there is one company up in Prince Rupert as well. But this story map is going to focus most in two regions specifically. One is the Salish Sea, here in blue, and then sort of the southern part of the Salish Sea and the west coast of Vancouver Island. So the whale watching industry has seen a number of changes in terms of management measures, both guidelines and also as mandatory regulations. And we put together this slide where it shows you sort of the timeline of where these measures were introduced and by who, if it was just Canadian or US, or by the Pacific Whale Watching Association, which is has subscribers from both Canadian and US companies. These measures, most of them apply both to commercial and recreational vessels that carry whale watching activities. I'm not going to spend a lot of time talking about AIS, because the figure most of you know about what AIS is. But I'm going to spend a bit more time describing the different type of AIS transponders and AIS data providers. So there are three main classes of AIS transponders, and these are equipment that the vessels carry on board and that send signals about the positions and other vessel information. And some of them can also receive AIS signals from nearby vessels and plot it on their plots. There's Class A, Class B, and Class B+. The main difference is in their transmitting power. So the Class A is the most powerful device where it's required on most commercial vessels by SOLAS, under SOLAS. And so these are large vessels, and they can transmit positions to between 2 to 10 seconds, but this of course varies depending on the speed of the vessel. The Class B are the units often carried by recreational vessels or small vessels that are not required to carry AIS. The transmission power is much lower, which means that they need to be closer to a receiver in order to receive that signal. Also, the positions are transmitted at a sort of higher, lower resolution, temporal resolutions between 30 to 180 seconds. And then we have the Class B+, which now they're becoming a lot more popular. They're a bit more expensive than the Class B. The Class A, they're the most expensive units. And they have higher transmission power and also transmit positions more frequently. Another main difference between the transponders is the transmission system. So there's the stoma and this scoma, which is hard to say with all the letters there, but mainly it's just the way the messages are transmitted and what type of messages they support. So I'm gonna stop here. There's more. There's another slide where I'm going to be talking more about, particularly the Class B, Class B+. And what we're focusing about these two units in particular is because these are the main units that the commercial whale watching operations will use. Some vessels have Class A, but most of them, particularly the ones based in Canada, will carry a Class B or a Class B+. And the whale watching industry now is required to carry Class B or Class A transponders since 2019, although we noticed that really they started implementing this change in 2020 and 2021. So in 2019, there's still a few several vessels that were not equipped with AIS in Canada. In the US, now they're all required to have AIS, but we noticed that it was AIS transponders were more present earlier on, and also because they're larger vessels as well. AIS data providers. So we learn a lot through this project about the type of data that you can access and its characteristics, its pros and cons. So we started with Exact Earth because it was part of the project, and they were able, part of the deal was to have access of data for free for the areas that we were interested in. So we thought, great, we don't need to look for more data. But we soon realized that particularly the resolution of the data, the temporal resolutions, the number of data points that we were obtaining from Exact Earth for the vessels that we were interested in looking at was very poor. Like we had messages every 3 minutes or more, depending on the area. And we soon realized that that was not going to work for us, because the type of work we wanted to do, we wanted the highest resolution of data as possible. So then we thought, we were looking into, and we learned about AIS Hub. So AIS Hub, it's an AIS data sharing center that provides access to free real-time raw AIS data to AIS Hub members. So what we did, and we have to learn to do that, and Andrea was instrumental in this, we figured out how to set up an AIS receiver on the roof of our building at University of Victoria. And in order to then feed data, so we had a receiver, we were able to feed data to AIS Hub, and in return, we were getting data from the network of receivers in the area. And that worked, and it worked really well. The only thing that we noticed then is that there's only a handful of receivers in this area and in the LSE on the west coast of Vancouver Island. Not enough to really capture what we wanted to capture, especially within the area. You can go to the website, I added the links here, and there's a map of where the receivers are from AIS Hub. So then it's like, okay, we need, the really only option we had left was Coast Guard. Getting access to the Coast Guard AIS data. And that took quite a bit of effort, but we managed to get it through the Ocean Nexus Canada. They have an agreement with Coast Guard. So we signed an agreement with ONC, and in return, we did a data request explaining the extent and the temporal the data that we needed. And after a few, it was also new for them to, I must say, to ONC. So it was kind of a learning process for both of us, for both our groups. But finally, we did get data, 4 years worth of data for the regions that I just described previously, and for all vessels. But then we just were, again, interested on the commercial whale watching vessels. So we have a list of MMSIs, and that's what we sort of looked. So I'm gonna meet this person. Right, so I'm just gonna go in a bit more in depth before I carry on with the Class B and Class B plus. So we had an opportunity to explore this in a bit more depth with a particular vessel that we equipped with. I'll just back up for a second. A part of the project too was we had these AIS transponders provided by exactors that we were giving to whale watching companies to put on their vessels. So we had a handful of companies that agreed to participate in the project. And one of the vessels is based in Ucluelet, and initially was equipped with a Class B transponder in August 2018. And then we actually gained access to a Class B plus transponder. So we equipped that vessel, we equipped the vessel with the B plus in August 2021. I think it was 2020, but anyway, the data shows 2021 here. And the main thing that I just want to highlight with these graphs is that the Class B, its reception was pretty good in terms of the terrestrial network. So data from Coast Guard was able to capture positions from SEND transmitted by this vessel. But you can barely see the number of messages received by the satellite network. But once we switch to the B plus, that really changes. Still, we get more positions with the terrestrial network, but the satellite, it really improved that reception with the B plus. And the main reason for this is, well, two main reasons. One is the transmission power is higher, but also these units, you can turn on the transmission of message 27. And my understanding is that these messages are transmitted on a different channel than other AIS messages and are less affected by noise from other radio frequencies. So this is something we discovered with the satellite AIS data is that it's masked. Their messages are masked, but in Canada in particular, it's an issue by the radio frequency in I think it has to do with the weather network or weather radio messaging. So it's really hard for the satellite to listen to those messages. But the B+, that, and because of that message 27, that is changing things. So I'm going to move on with that. So here, just looking at the data that the vessels that we were looking at and analyzing. So for the South Coast, the kind of light blue shows the number of well watching vessels that were equipped with AIS, and you see the numbers have slowly increased from 2019 to 2021, mostly because vessels and companies had the time to acquire the units if they didn't have one already or was not provided by us, and install them. Also, came the COVID pandemic, and that it's a theme that keeps showing up in our data. It made a difference in terms of operations and the number of data and vessels in the water. But nevertheless, another thing I wanted to point out is that, particularly in 2019, that only a fraction of the well watching fleet was equipped with AIS. More than I would say, more than half of the fleet still was not equipped with and actively operating in the south coast of the Celeste Sea were not equipped with AIS. So this is significant when we're going and interpret some of the data that I will show later. In the west coast of Vancouver Island, we don't have numbers of the vessels not equipped with AIS for each of these years, but we have numbers of the number of vessels that had AIS and how that changed. Again, some vessels just didn't operate, stay, in dry dock or whatever once the pandemic hit, and then there was slight recovery in 2021. So we're getting into the data analysis. So as I said before, we chose the Canadian Coast Guard terrestrial AIS data as our main data, AIS data to analyze. And here I'm just going to talk about two main sort of outputs from the data set. One is a whale watching trip, and then a potential wildlife viewing event. So a whale watching trip is a trip derived from AIS positions with a start and end point at the home port. And we define those whale watching trips if it lasted at least 2 hours, but no more than 5.5 hours. And they need to have at least one potential wildlife viewing events. Some of the trips, there were not whale watching trips. Some of the trips were a vessel based in Victoria needed to go repair their vessel, do some maintenance out in Sydney, for example. So we have those trips, but those were not, we had those positions, but those were not whale watching trips. So they were removed from the data set. A potential wildlife viewing event is a set of AIS points, which from a known commercial whale watching vessels that are likely engaged in a wildlife viewing or searching for wildlife. We limit those events to between 10 to 60 minutes long, so an hour, and at a maximum speed of 12 knots. So they could be just stationary, so 0 knots to a maximum of 12 knots. And we remove any points that from the wildlife viewing events that were within like narrow passages or harbors where most likely they were going slow because they were exiting a harbor or was narrow passage, so they have to navigate slowly. So just to avoid some false positives, we'll remove those data points from the data set as well. So I'm going to switch now to Andrea, who she's going to talk about how, and this is really the work of her thesis, how she identified those wildlife viewing events.
Thanks, Norma. So For a couple of years, I was working on different classification models and conducted an evaluation on the accuracy and utility of these models for detecting commercial whale watching vessels and their behavior, or when they may or may not be engaged in a wildlife viewing event. And I found 3 classification models of different types that would give us a variety of possible variables to look at, as well as different methods to see which was best for its utility in detecting wildlife viewing events. So those 3 different models are all machine learning models, which are automatically learning patterns within the data, either from a statistical or non-statistical method, and can be used to make decisions under uncertainty or without prior knowledge. So the 3 models used a subset of whale watching trips from one single vessel out of the Victoria Harbour collected by Molly Fraser in 2019. And there's only 20 whale watching trips used. I compared density-based spatial clustering application with noise, or I might say DebScan for short, going forward, which is a non-parametric modeling that looks at the density of geographic locations of points. That was the variable that we use, but it could be used with multiple variables in a multi-dimensional fashion, which might be worth looking at in the future. But we did end up choosing the hidden Markov model, which is a state-based stochastic model that represents the probability distribution for a sequence of AIS points. And in particular, the hidden Markov model takes into consideration the point previous to the current point that we're looking at. So if we're trying to classify point with the letter A, we're going to look at, A minus to see what the state of that point was prior to. Logistic regression is a discriminative classification algorithm that is used for binary classification, so just wildlife viewing versus non-viewing. But it was also valuable because it provides a level of influence called logistic regression coefficient of the variables on the model. So it gave us an understanding on how time, speed over ground, course over ground, geographic location, turning angle, and distance might impact these detections of wildlife viewing events. So if you can go down, Norma, please. Thank you. To select the model, we looked at different statistical measures that would represent model performance. Overall accuracy isn't always the best measure. So the F score is a harmonic mean of precision and recall. So it essentially tells us how likely the true positives and true negatives, false positives, false negatives, the classification, how likely it was to be accurate. We also looked at the logistic regression coefficients, which supported the use of the speed over ground for the hidden Markov model state-based approach. So once we decided to use the hidden Markov model based on the accuracy measures, we were able to confirm the use of speed over ground. And if you go to the next phase, please, this next slide, I suppose. The next phase of the research compared a supervised method versus an unsupervised method. So machine learning supervised methods, you require prior knowledge, and you use that knowledge to train or have the machine learning algorithm learn the pattern of the data. Unsupervised is when the model, the classification model, learns the pattern of the data itself. So the 2 graphs in this picture show how the supervised method is kind of very accurate, accurately fitting the curves of the speed over ground distributions. And there's 2 distinct curves for viewing and non-viewing. Unsupervised isn't quite as close, but the benefits from that is that you don't need any prior knowledge. And we were trying to reduce the reliance on observed whale watching behavior data because it doesn't exist for a large geographic region. And we also needed data that was very specific. So Molly Fraser's data sold us down to the minute exactly when the vessel was watching or not watching an animal. And we don't have that information for the entire fleet. So it would be very difficult to collect. And so we wanted to make sure that an unsupervised approach would be able to be sufficiently accurate when compared to the supervised approach, and then take into account the facts that we don't have all of that information. We don't have that prior knowledge that was required. if we scroll down a bit more, Norma, it just goes into how we did do the same statistical tests and that it did prove that the unsupervised method was sufficient while we're still reducing the reliance on that data. And there's a bit more, my thesis is linked here if you want to get into the nitty gritty, but I'm going to try not to get too technical here. Thanks, Norma.
Excellent, thank you, Andrea. So yeah, we're getting now into showing you some results. So these maps show the density of whale watching trips, the number of vessels per cell, commercial whale watching vessels from 2019, 2020, and 2021. So we can see, for example, clearly how the reduction of number of trips between 2019 and 2020 because of COVID. Also, although the extent of it, if we're just looking at how far the vessels were going, it didn't really change that much. It's just the number of vessels or trips got reduced. And then we see an increase, a slight increase from 2020 to 2021. And I'll expect that now in 2022, numbers are going to be back up to 2019 levels or higher. But again, I'm pointing out, for example, that 2019 only represents a fraction of the actual whale watching activity in the area, because as I mentioned before, only a portion of the whale watching fleet was equipped with AIS, and particularly vessels operating in Canada. This map now shows the number of wildlife viewing events per year. And again, we see, because it's really comes from the same data, a reduction in the number of wildlife viewing events in 2020 and 2021, maybe a slight increase, but it's hard to tell with these figures. Also, it's interesting to see that there are some hotspots, areas where the number of wildlife viewing events, potential wildlife viewing events, is they're high compared to others. So those darker orangey red colors, and how some of those hotspots sort of stay in time, maybe reduced, but still visible. And I'm just going to walk you a few applications that I thought that this data could be used for. So for example, one is monitoring compliance. So in 2019, so for example, we can use AIS data, commercial whale watching data, for monitoring the compliance of regulations that particularly affect commercial whale watching vessels and other vessels in this case. But you know, it tells you where the vessels are, and then you can look at temporally how that compliance change if there are areas where they're not allowed to go. So for example, in this case, we have Saturnus Island interim sanctuary zones. So the interim sanctuary zones were introduced by Transport Canada, I believe I'm not mistaken, in 2019, and after that every year. And so we can use these data to look at where commercial whale watching vessels complying with these zones where no vessels of either any kind, really, although there's some exceptions, are allowed to enter. So if we can use this slider, you can see that the map on the left shows 2019 and the map on the right 2021. And so you can see that the reduction in the number of vessels in that area. Another application, for example, is looking at the level of pressures from tourism industry, in this case, again, commercial whale watching vessels in insensitive or protected areas. So one of those hotspots that we were able to see in the wildlife viewing events comes from, it's linked to the Race Rocks Ecological Reserve. So that area, it's rich in biodiversity and a number of species. There is sea lions in the rocks and seals, and there is also elephant seals, and the water surrounding Race Rocks is also rich. You can cite humpback whales and killer whales. So it's a very popular destination for commercial whale watching vessels based out of Victoria, but also based out of operating or US vessels. So with this, we can see that in 2019, we detected up to 1,000 visits that year. There's again a reduction in 2021 and in 2020 with around 700 visits, but still is the area most visited by commercial whale watching vessels in the Sallee Sea. So again, you can just explore and then you can look at all the areas as well this way. And another one I thought it is just, kind of interesting. You can't just rely on AIS data to get at this, but we ran a series of interviews with commercial whale watching operators with the results of this study, because as a way to validate the results. And it was very pleasant surprise to realize that, yeah, our results sort of match their knowledge of being in the water, and that some of the hotspots that we were seeing with the wildlife viewing events are true hotspots, in the sense that they visit those areas because there's some wildlife present to go and see. So I thought if we can explore some of these hotspots. So for example, and this is from 2019, so that area here just south of San Juan Island, that's an area that they go visit for minke whales. These are an area often visited by where you can do some humpback whale sightings. These areas for gray whales. This one on what's this island again? Whidbey Island, yeah. This area, it did show up in 2019, but it didn't show up in other years, 2020 or 2021. So that was interesting. I don't know why exactly, but when I asked, yeah, that was gray whales in that area. And in this one, just says upside Everett, it shows every year for gray whales. And then we have some rockeries with sea lions, and there's probably a few more that I didn't mark with the pins, but those are areas that almost guarantee of some kind of wildlife sighting when they go, because they don't tend to go very far. I mean, the sea lions. And so just to summarize, these are just a few points that I wanted to highlight. The first one is that I think it's very important to have a good understanding and really, depends on what you want to do with AIS data, but you want to have a good understanding of the different transponders used by the vessels that you're investigating. And then the data that you have access to, is it satellite, is it terrestrial? If you have both, maybe you want to integrate them, because it will really affect the analysis and the results that you're getting from the AIS data. The AIS data is huge, especially when you're looking at multi-year type analysis. So having tools like machine learning and data mining are fundamental, especially if you want to maximize the potential of the AIS data. And its applications are numerous. I mean, I just pointed out 3, but we can do a lot more with it, and it can inform our spatial planning. We can look at fleet management. So at from the operators' points of view, they saw AIS as a tool to manage their fleet and sort of coordinate when a vessel is out, when is another out, and to maybe even reduce the presence of these vessels at particular times in certain areas. So that was kind of an interesting point, talking to the commercial whale watching operators, is how they can use real-time AIS data to better manage their activities. And with that, I just want to acknowledge a lot of people, and here are the icons for the participating whale watching operators, our funders. A few people were involved in the project, and I just added the link or our email addresses if you want to contact us. And yeah, with that, I'm done. I don't know where I'm here with time, but I haven't hopefully not
Thank you
done
so
too
much, Norma. That was really, really interesting. And I love the story map approach. I think we have a couple of questions on deck. So we'll go to those quickly. And then as we're a little bit over time, we'll be moving on to our next presentation. But our first question is from Lovell Pratt, and she's wondering, are Washington State commercial whale watch vessels included in this study?
Yes, they are.
All right, and thank you for that. And then Ron, I'm seeing your hand. Go ahead.
Yeah, thanks, Norman and Andrea. That was very well done. A couple of short questions. Why does your story map end after July? Is it a UVic arrangement thing? Like,
Yeah.
I'm wondering if we have the same problem at Dalhousie.
Yeah, no, it is. And I begged to keep, I was ending in May. And I was like, please, can I have it for 2 more months? And yeah, but I'm working, I'm gonna see if I can, the plan is to build, maybe not the same style story map, but similar within DFO, but they have the level of logistics and admin around that. I think it's gonna be tricky, but I'm gonna find out. Alternatively, Andrea, for example, has a personal license, so we might move it to her account. We'll figure out something, but yes, that's the limited is UVic, geography department.
It just depends who works where and what license. Okay, thanks. Did you compare accessing marine traffic versus AIS hub in terms of setting up a receiver? And yeah,
we did explore that. The only problem with marine traffic is like, yes, they take our data, but they were not giving it back for free.
oh, I thought they were. Okay, I never did it myself. Okay.
No, and it was great for a while. We were bidding both, but at some point we have an issue where it stopped working with marine traffic. So we just stay with AIS hub because marine traffic, a lot of more users know how to use marine traffic, and it just adds to the coverage. But it just stopped working and we couldn't figure out how to fix it. And then at the end, we didn't really need it. So.
Okay, and one last question. You may not be the right person to ask, but since B plus is much stronger than AIS Class B, do you think Class Bs are just going to be obsolete and disappear, or do you think both types will continue?
That's a good question, but I will say I think people are still learning about B plus, especially, maybe recreational boaters. I think they're about $200, $300 more expensive than the B. So that's another issue. But they're just making, there's some much better than B.
Okay.
At least depending again, but yeah, so.
Thanks very much.
And we have one more question. This will be our last question. Unfortunately, we have to move on, but JD Leahy from Washington Ecology has asked, how did you identify that a vessel was a whale watching vessel or some other kind of vessel?
We had a list. We had a list of MMSIs for the commercial whale watching fleet, both from the Washington, based in Washington and based in Canada. The list was provided by the Pacific Whale Watching Association. The ones in the West Coast, it's a smaller fleet, smaller group, and we were able just to go and look at using marine traffic, looking by name. So we did several things, but we verified that the vessels that we were looking for, that we were including in our analysis, were commercial whale watching vessels. Maybe we missed 1 or 2, but we really try to make sure we didn't miss any.
Thank you so much, Norma and Andrea. That was really interesting. Love the story map approach. And as Norma's put that in the chat, if anybody wants to explore more and play with those fun maps, you can do that. And hopefully we'll have a little bit of time at the end for more questions if there are any more for Andrea and Norma. But now we're going to move over to Leah's presentation. So Leah is going to be sharing with us the collaborative remediation of abandoned, lost, and discarded fishing gear in Southwest Nova Scotia. And I'll let her get into what her project is about, but Leah has a bachelor in community design and an honors in urban design and planning and a certificate in geographic information systems from Dalhousie University. And she most recently completed her Master of Marine Management at Dalhousie. And she's currently working towards a certification to become a registered professional planner under the Canadian Institute of Planners. and she's interested in the fields of marine spatial planning, landscape connectivity, and seafloor mapping. So Leah, please take it away.
Thank you so much for the introduction. So good afternoon, everyone. Good morning, wherever you are. My name is Leah Fulton, just as mentioned, and I'm excited to be here today to talk about the collaborative remediation of abandoned, lost, or otherwise discarded fishing gear in Southwest Nova Scotia, where I will specifically be touching on the use of AIS data for gear detection and derelict gear retrieval. So before I begin, I'd just like to acknowledge that this work was completed on Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people, and we acknowledge them as the past, present, and future caretakers of this land. And we are all treaty people. So I'm just going to close my camera for this presentation, just to ensure there's no issues with bandwidth, but I'm still here. So as part of my master's research project at Dalhousie, I worked closely with Coastal Action, an environmental nonprofit organization based in Mahone Bay, Nova Scotia, working on the collaborative remediation of abandoned, lost, and otherwise discarded fishing gear in Southwest Nova Scotia. So this project partners with industry, academia, and government to prevent, reduce, and assess impacts of abandoned, lost, or otherwise discarded fishing gear on the South Shore of Nova Scotia, specifically in lobster fishing areas 33, 34, and 35 on the Nova Scotia side. And this work was done over a 2-year project period, commencing in July 2020 to March 2022. So abandoned, lost, or otherwise discarded fishing gear, ALDFG, is considered fishing-related debris that is either accidentally or deliberately disposed of into the marine environment with the ability to cause significant environmental and economic impacts. It is considered that 1/5 of all marine debris is estimated to be generated from marine-based sources. There are many different ways that fishing gear can end up in the ocean. First, it can be accidental. And fishers are not always at fault, as the marine environment is shared with other industries. Often fishers do not want to lose their gear because it represents lost catch revenue, lost expenses towards gear, and lost time managing gear loss. Ghost gear can be generated with conflicts by conflicts with other industries like shipping, aquaculture, and just general fishing congestion. These encounters can sever buoy lines by other vessels or snarl onto active fishing gear, ultimately compromising the economic efforts in fisheries. Storms and unfavorable environmental conditions can further contribute to lost gear totals. And without robust recycling programs in place, inappropriate disposal at sea and poor gear conditions can generate more ghost gear as a result. So ghost gear has different negative environmental, social, and economic impacts, which makes this a really important issue to solve. For target species such as lobster, lost traps can indiscriminately capture bycatch for long periods after the trap is lost due to the ghost fishing cycle. And the baseline assessment research from this project resulted in an estimated commercial loss of target species upwards to $172,000 Canadian annually. In terms of environmental impacts, this ghost fishing cycle can also trap species that aren't targeted as part of the fishery, like some species at risk, or entangle marine mammals, resulting in extensive injuries, deter their ability to reproduce and feed, starvation, and possible death. Also, dynamic ocean conditions and lost gear can damage benthic ecosystems that are essentially developed, that are hosted on the bottom of the ocean, and also lead to provide unsuitable habitats from ghost gear being kind of stuck in the bottom of the seafloor. So, for those who don't know, Southwest Nova Scotia is considered the most productive American lobster fishery in Canada. The commercial American lobster fishing industry is one of the most essential industries in Nova Scotia, and contributes to over $500 million each year. A little research has been done to understand the negative effects of ALDFG on commercial fishing markets, target species, and their marine environments. But from the available published research available and local evidence, ghost gear is clearly a serious problem. So when we look at the historical fishing activity data within the region of Southwest Nova Scotia, Clark's Harbour revealed to be the highest number of traps per kilometre squared at 13,771 traps per kilometre squared. Given that this research was done in 2014, this has since expected to increase due to the higher demand within the industry. So how do we start by identifying areas for ghost gear retrieval? Well, in order to identify retrieval areas, there are several techniques that were deployed. In 2020, 3 focus group sessions were held with the Brazil Rock Lobster 33-34 Association and with the Cold Water Lobster Association. These commercial fishers that attended focus groups identified areas of frequent gear loss based on known fishing grounds, while also referring to their own AIS data, as well as things like environmental conditions, complex and known historical areas of gear loss, which helped us kind of understand where retrieval captains would prefer to retrieve and conduct retrieval missions. In addition to selection of these areas, we also use reported lost fishing gear. So as part of the conditions of groundfish and shrimp fishing license in Canada, lost fishing gear is required to be reported to the Department of Fisheries Oceans Canada since 2020. License holders are to report any gear within this 24-hour period to contribute to the database of lost gear. The data used for this analysis within the entire Coastal Action Project represents fishing gear up until June 2021. So I won't be able to go into the details too much about what AIS is, but I will go into the details about how it's used in retrieval missions. So within kind of retrieval missions, there's 2 distinct parts that we kind of used in this project: gear detection and gear retrieval. So AIS data was used in conjunction with side scan sonar data and GPS positioning, acquisition, software for gear detection. While gear retrieval, we use Fisher's Intel to determine search areas. We used AIS data to understand kind of towing patterns, as well as AIS data from the retrieval operations to provide insight into future retrieval missions. So due to the privacy of this kind of work and just kind of our confidentiality agreement, I won't be able to show AIS data from the gear retrieval operations. So in order to retrieve ghost gear, it's important to know where to look. Gear detection can essentially be introduced as a method to predetermine locations of ghost gear in order to facilitate and speed up the retrieval process. In 2017, the Global Ghost Gear Initiative highlighted side scan sonar as a primary tool for gear detection. And side scan sonar systems essentially record a swath of sea floor to produce an image pertaining to the superficial seabed characteristics through acoustic data. These instruments can be mounted on a tethered towfish and towed behind the vessel or mounted on a remotely operated vehicle. So for my master's project, in part of this whole work, my project looked at evaluating the effectiveness of this technology as a gear detection tool for large-scale retrieval missions and understand the feasibility of this work for future applications. Because of these international initiatives promoting, the use of side scan sonar, there wasn't actually a whole lot of published literature available pertaining to the detection of ghost gear and how this affects the subsequent success of retrieval operations. So essentially, this was looked into further within the geographic context of Clark's Harbour in June 2021. So I won't get too much into the nitty-gritty of the project, the research itself, but here's a quick screenshot of some of the tracks completed showing the GPS tracks around Cape Sable Island within the Clarks Harbor region. So based on a combination of environmental parameters, reported last year coordinates, Fisher's knowledge, and AIS data, a 9-day side scan sonar survey was completed in June 2021, where 17 transects of high quality seafloor imagery was obtained. The preliminary identification of contacts, so of ghost gear contacts, prior to post-processing, revealed 161 targets identified. These targets were provisionally identified as lobster traps and other unidentified marine debris. So upon a second comprehensive review of the side scan, following post-processing of the data, we concluded that there was 114 potential targets, revealing that many of these initial targets were unlikely to be ghost gear. Within this area alone, there was 2,000 or just over 2,000 kilograms of gear removed from the benthic environment during the 15 days allocated. There was 91 kilometers squared of high quality seafloor imagery collected from the seafloor, and 55 items were retrieved from the benthic environment. However, only one of those items was confirmed retrieved from the identified contacts from the side scan sonar imagery, revealing that much of the gear that was retrieved outside of the side scan sonar transects. So here is an image of a lobster trap that is shown on the bottom of the seafloor, circled in the white, just to kind of give you an idea of the kind of imagery that we were looking at within this part of the project. So during the retrieval operations that occurred in year 1, which would be 2020, and year 2, which is 2021, 10 vessels towed grapples for nearly 4,000 kilometers, searching the floor for ghost gear. So this trail map was created using the latitude and longitude coordinates of essentially each location from when the grapple was submerged into the water to when the grapple was removed and the towing stopped. This essentially allowed us to calculate our distance search, and this method was used in place of the absence of AIS data in case if an area were to occur, and essentially was also used in reference to the AIS data that we were able to obtain. One limitation of this retrieval tow data is that not all the tracks from the vessels are linear, and in some cases the start and end tow coordinates did not necessarily reflect the actual length towed. So this is when we refer to the AIS data. The retrieval tow distances were based on coordinates of, like I said, when the grapple was submerged into the water. And as you can see, there are different types of kind of towing patterns within each of the areas. So in kind of the Tiverton region in the figure A, we can see a more linear kind of focus in terms of search area, whereas in comparison to figure C, there's a lot more zigzag movement and smaller tow lengths in comparison. So a total of 24,630 kilograms of ALDFG was retrieved from the ocean surrounding Southwest Nova Scotia, and over 4,500 kilograms from 7 shoreline retrievals, totaling a near 29,298 kilograms of ALDFG removed from this region. So of the debris that was removed, 68% were lobster traps and 12% was drag rope cable by weight. Some other really interesting highlights of this project were that over 25 different species were released from ghost gear that was retrieved. including 652 lobsters and 57 fishes, of which 42 were species at risk. From the data that we collected and the knowledge on trap loss within the region, an economic impact assessment was done, and it was estimated that a trap loss of 2% can create a 71,305 to 155,000 commercial loss annually from decreased catches within LFAs 33, 34, and 35. So there are some challenges associated to using AIS data in this kind of work. The first being AIS software compatibility, and that not all fishers use the same AIS software, and some fishers required hands-on data offloads, which essentially can slow down the process of putting AIS data onto our own computers, visualizing it spatially, and informing retrieval missions. And in some cases, there was some issues with offloading that data. So this is why we use the tow method in case if there were any issues. Another kind of leading into that is data transfers and sharing. So because of a lack of direct data translation to retrieval vessel AIS devices, this did create some difficulties in uploading locations of lost gear for those targeted retrieval missions. Given the restricted use of technologies and perhaps a lack of comprehension for data sharing, retrieval captains were unfamiliar with downloading different sharing browsers and whatnot. So it was hard to work remotely in that kind of sense. And without those exact format data transfers, it's uncertain whether those data transfers were even useful in large-scale retrieval missions. Sometimes fishers were reluctant to share AIS data as searching may have occurred in areas where there were target species present, ultimately contributing or kind of hiding or not necessarily wanting to share for competitive purposes. And using the spatial data in addition to fishers intel was quite impactful. But had this been done in a COVID-free time, we would have certainly loved to combine both spatial data from AIS and our tow missions, as well as fishers intel within a mapping exercise to essentially understand and better navigate retrieval missions moving forward in Southwest Nova Scotia. So I've included some images here to highlight the extent of the efforts from this project. As you can see, there's really everything from lobster traps to certain habitats growing on kind of biofowl on different fishing types. So whether that be rope or lobster traps, as well as even pulling out some aquaculture netting, as you can see in the bottom image there. And then so if you are interested in learning more, I do encourage you to check out the Tale of Lost Fishing Gear. This is a story map that was created about this project, and I will link it in the chat when I'm done this presentation. And I just want to thank you so much for listening in today. And I'd also like to thank our partners in this project, as well as Fisheries and Oceans Canada through the SSFRS program. And if you have any questions, I'm happy to take them right now. And if not, you can feel free to email me at leah.fulton@dal.ca or Ariel Smith at ariel@coastalaction.org. Thank you so much.
Thank you, Leah. That was a really great presentation, and I think really highlights the magnitude of the issue of ghost gear and the impacts that can have. Small story, my best friend's honeymoon was derailed by a crab trap fouling the propeller of a BC Ferries vessel, and she couldn't go to Haida Gwaii. So it's a real problem. Does anybody have any questions for Leah before we move on to our next segment? I think it was particularly interesting to see the different patterns of movement as ships or the vessels were looking for lost gear and retrieving lost gear. And I think AIS is really, really great to show the differences in movement there. And my hat off to you for being able to identify a lobster trap at the bottom of the ocean from that image. That I think is an acquired skill for sure. Right. And if you have any questions for Leah, please feel free to, you can drop them in the chat or put up your hand. And I will also note that if you are somebody who uses Twitter, we have some tweets happening on at clearseas.org. If you want to share or retweet any of those, we encourage that sort of thing so that people can find out about the exciting work that people are doing with AIS and maybe encourage them to sign up for future webinars. All right, so it looks like Leah may have answered all of the questions in her presentation that people may have had, but if there are any more that come up, please put them in the chat or you can contact Leah directly later. So I think we'll go to our break now. We're going to have a short 10-minute break. Feel free to have a stretch and get some water, and then we'll come back to hear the work that Mark Stoddard has been doing in the Arctic. So we will reconvene at 20 minutes past the hour. Thank you all so much. I'd now like to move into our last presentation for today's session. We're going to be hearing from Mark Stoddard about the work that he's been doing related to example use cases of historical satellite AIS data for the analysis of maritime activity in polar waters. So we'll be now moving from the Atlantic to the Arctic region and hearing more about some of the challenges in that area. So Mark has a range of different research interests, including Arctic maritime remoteness, Arctic navigation, maritime risk assessment, and operations research. And he's currently focused on extending existing land-based measures of remoteness into the maritime domain and developing new measures to address the unique challenge of measuring maritime remoteness in the Canadian Arctic. Mark is currently working on his PhD at Dalhousie, and he is also a defense scientist working for Defense Research and Development Canada, DRDC. Since joining DRDC, his research has focused on Arctic maritime domain awareness, undersea surveillance, and acoustic intelligence operations. Mr. Stoddard is currently the leader of the Operational Analysis and System Integration Support, or OASIS group, at the DRDC Atlantic Research Center in Halifax, Nova Scotia. So Mark, please go ahead.
Okay, I'm assuming everyone can hear me. Can you confirm?
Yes, loud and clear.
Perfect. Okay, thank you so much. So today I'm wearing purely a student hat, so no reference to DRDC except a few logos in my presentation. But for the last little while, I've been a PhD student of Dr. Ron Pillow, who's on the line today, looking primarily at Arctic maritime risk assessment, most broadly. And today I'm going to talk a little bit about my PhD research, but try to emphasize just the work we've done with satellite AIS data to look at how we use it in a variety of ways to support the analysis of maritime activity with emphasis in polar waters. Now, so yeah, a little bit in the background. My research is looking mostly at developing year-round measures of maritime remoteness and accessibility for coastal communities in the Canadian Arctic, with most of an emphasis on accessibility. Obviously, everyone recognizes that going to areas of the Arctic in the middle of winter is far more difficult or challenging than going there in the summer due to the presence of harsher ice conditions in the winter months. So some of these communities become far more remote when you look at transportation time to get there by certain classes of ships based on the time of year. And so what we're trying to understand is by using these better knowledge of the sea ice conditions and the capabilities of ships, we can start to look at how long it could take to get to communities like Iqaluit, Pond Inlet throughout the year, and try to use this to better understand remoteness and accessibility within that region. So currently there's a gap in tools for that, but I'm not really going to focus on those discussions. Most of today is about the quantitative methods that we're developing to support this research. Two main methods. One's focused on navigational risk assessment. So looking at how we incorporate ice into risk assessment for ships transiting in the north, and transit time estimation. So these are the techniques we use to use this knowledge of the ice and the capabilities of the ships to operate in ice and how that can then impact transit time in the north. And AIS data, its primary use within the PhD and within this work is to help us better understand polar vessel speeds within different ice regimes and how those relate to the various risk levels, which I'll speak to a little bit later. So AIS, I guess we've already talked about it. Being the third presentation of the day is a bit good because I don't have to go over what AIS is. Obviously, it's a system that's been around since, well, 2004 and before, to share information, position and identification information among ships with coastal authorities, and more increasingly, more with academic researchers to support a variety of different studies. Its use is mandated on most large ships. And the early days, it was mostly terrestrial AIS networks, networks of shore-based receivers that would pick up ships as they got closer to ports and harbors. Where now with satellite AIS and the rapid commercialization of satellite-based AIS reception, it's used for global vessel tracking for a bunch of private, government, academic initiatives, and supports a lot of different research into maritime transportation. So the AIS data set that I'm working with was provided by the Dalhousie University Institute for Big Data Analytics. Casey Hilliard, if many of you know him, he's been kind of assisting me, or was assisting me. I think he's left Dalhousie now to move to private industry, but he helped me pull out a subset of the AIS data that they had. It covered 2018 and 2019. It was mostly a polar data set, so mostly interested in 60 degrees north to the pole, circumpolar, and it rounded out to about 20 million messages, individual messages in our area of interest. And a lot of my work, because I'm looking at Arctic navigation and I'm looking, trying to understand vessel speeds. Well, a lot of that I want good data. Not all ships are doing safe operations, or that are, some of them are just doing different types of activities. So I really wanted to focus on experienced polar ship operating fleets. So the four companies I'm mostly focused on are FedNav, Desgagnés, Coastal Shipping Limited, and NIAS. So they do a lot of the community resupply runs in the north. They service a lot of the iron mines and diamond mines up on Baffin Island. And they're the fleets that I would expect to be mostly, trying to go from A to B as expeditiously as possible, but also have a lot of experience. So the vessel speed observations of those ships carry a bit more weight with me, because I know they're not doing anything funny in between or during their transit. If I incorporated Coast Guard ships or survey ships, well, they'd be doing, they'd be slowing down in different areas, not because of the ice conditions, but maybe because they're doing survey operations. So I really wanted an easy way to get rid of those anomalies from my data sets. So I focus on ships that are primarily, going from A to B as expeditiously as possible. And we pulled all these vessels out for the 2018-2019 timeframe. Right, so getting into one of the two things I'm going to talk about today is, because I'm looking at Arctic transportation in the north, it's pretty big challenge to include maritime transportation in quantitative studies, mainly because navigation is relatively unconstrained. Obviously, ships have a lot of freedom to maneuver. So one of the big things we worked on with some folks at the Coast Guard and within the Navy is to develop a transportation network, essentially connecting the various communities we were most interested in the Eastern Arctic. And we call this the Trusted Routes Graph. So this graph was actually derived from routes that were produced by the Coast Guard and Navy navigators, and then joined together into a network. The challenge we ran into, which we didn't really anticipate in the beginning, was trying to find ways to represent the actual communities. Obviously, if you try to get a community, like the location for Baker Lake or Rankin Inlet, you can go on Wikipedia and get a Latin long, but usually that Latin long is the city center on the shore. And then when you try to figure out, well, how do I represent that node within the maritime domain? Obviously, that would, and I would imply the safe water near that where a ship could anchor. because not all these communities have shoreside infrastructure where a ship could pull up alongside. We had this problem of trying to figure out where we wanted to represent the communities that was in the maritime domain, in the water, but where we knew ships would be able to get to. Because we're developing quantitative methods, it's really important for me to have feasible paths into the community. So I couldn't just arbitrarily have the network terminate at the coast or at the dock side. So we used AIS data to actually try and determine where ships are in around those communities, where would they actually anchor. So the way this looks like is we would take the AIS messages in and around communities, filter it for when they had either they were broadcasting a navigation status that they're anchored or that they had a vessel speed reported at 0. So we get all these messages and then we apply some basic clustering algorithms to determine a point that can best represent the cluster of positions. And these points are what we use as our maritime node representations for those communities in our transportation graph. So the figure on the left, the blue, well, they're crosses, but you can hardly see that they're crosses, are all the individual AIS messages, the 1, 2, 3 messages. And the red star on the left side is the center point of the cluster, or what the results of the clustering. And when we showed on the image on the right, just to kind of show you what I mean, yes, there's a short side dock, but it's really only suitable for small vessels. But most of the vessels doing the community resupply are quite large, and they usually anchor offshore and either barge in their fuel, or in this case, use umbilicals to land fuel. So that was the whole goal of this clustering, is to try and figure out where do the ships actually stop when they go to these communities. And that's what represents the node that we use to represent those communities in the water. So we applied a similar approach to all the different communities in the Arctic we were interested in this case, Cambridge Bay, Ugalulik, Pond Inlet, another one, just to kind of show you these communities aren't very well developed, and the shoreside infrastructure is very lacking, and the ships very rarely come very close to shore. So in this case, the AIS data provided a very useful data set to try to, as accurately as we can, represent the locations where ships actually expect to be their destination in and around these communities. So that's it for that one use of AIS, which is how to determine where ships actually stop, or what is the destination in the Arctic for some of these communities that don't really have docks alongside. The next one's going to start to bring in the main focus of my PhD work is on ice risk assessment and its impact on ship operations in the North. So in this case, we rely on an industry tool called Polaris, the Polar Operational Limits Assessment Risk Indexing System, a bit of a mouthful. And what it is, it's a framework that allows ships and ship operators to assess the safe operational limits for a particular polar class ship in the ice. Its use is recommended as part of the International Maritime Organization's Polar Code. So it's used throughout the world, including within the Canadian Arctic. And the output is what we call a risk index outcome, which will be important in some later slides. But the way it works, it's a very simple, practical system where you assess an ice regime. You have some knowledge of your ship's polar class and its capabilities in the various ice regimes. And then there's risk values that are associated with each of the ice regimes. And you end up doing a simple little, some addition, a little bit of math, very simple math. They do it on the bridge of the ships to determine traditionally it was a go, no-go style decision, but now it's more of a go, no-go, or proceed at risk or proceed at caution type of output. And this is what we use to kind of determine how we expect ships to operate in varying ice conditions. So what we do is we use a lot of historical ice information provided by the Canadian Ice Service. In this animation, which is a bit dated now, we used ice data from 2007 to 2014. And the Canadian Ice Service produced weekly sea ice charts for the Canadian Arctic. And we're able to use historical sea ice data and use the Polaris ice risk assessment to start to look at how the risk changes throughout the year, depending on the week that a ship may be in a certain specific area in the north. And this is kind of what we use to look at community accessibility. So as the ice melts and the waters open up, communities become much more accessible, especially when measured in the time it takes to get there from different locations. Back to how we use AIS. So as I mentioned, one of the big things we're interested in is transit time estimation. Well, luckily with AIS, in this case, we have a ship that's leaving Gascoyne Inlet, which is a small little inlet on Devon Island, heading down to Cambridge Bay. Using satellite AIS data, I can see its track. That track tells me the route that it executed and how long it took to get from the start point to the end point. And what we do is we look at traditional ETAs, which are normally computed, as a speed times distance. And normally a ship likes to operate at its max economic speed. Well, in the Arctic, that's kind of not really a feasible way to generate a good estimate. So typically they use a conservative estimate of, say, 8 knots. We expect to average 8 knots over this transit, and then they can get an estimate of how long it's going to take them. What they traditionally have never really considered is how their route intersects with the current ice conditions. So in this case, we're showing a route that was executed on August 30th, and we're showing a sea ice chart that corresponds to the exact same time. And what we've done is used our ice risk assessment to determine what the operational constraints might be on that ship, or the risks. And then now we're going to try to incorporate these risks into our transit time calculation. The idea being, if you're in green, that means it's completely unrestricted, safe operations. You can probably go faster. And obviously, as you go into increasing levels of ice risk, whether that's the yellow, the orange, or the red category, we try to adjust the speeds to account for the increased ice risk that's present. So what you end up getting is a route that was executed, and we look at how it intersects with the ice risk. And then we apply speed corrections. So in green, I think I was using for this case 12 knots. In yellow, it was 8 knots. In orange, it was 5 knots. And in red, it was 3 knots. And from this, we start to produce what we call ice risk adjusted estimated transit times. So in this case, if you used a traditional ETA, assuming I'm going to average 8 knots for the entire duration, and the distance is 523 nautical miles, it would take you about 65 hours. For the ice risk adjusted ETA, we end up getting a 93.6 hours. Using the AIS message that corresponds to when they left Gascoyne Inlet to when they arrived at Cambridge Bay, it worked out to about 107 hours. So we see that adjusting there is obviously a need to adjust for the ice risks along the route. And the facts that we have this information, the Canadian Ice Service provides it. What's lacking is the quantitative methods to make it easy to do these calculations for the ships. And that's kind of where we're very interested, is to develop robust, reliable, quantitative methods to improve the incorporation of ice risk into transit time estimation in the Arctic. So to conclude, moving quickly along here, AIS data continues to play an important role for the development and mainly the testing of the quantitative methods we're developing for my PhD and for this region. So we're trying to improve, what are the ship speeds adjustments we should be using for the various risk categories, and trying to use AIS data for quality assurance. So we pick routes that we know were executed by trusted ship operators that have experience and how long it takes them to navigate that. And then we try to tune and test our methods to ensure that we're getting reliable results that are, applicable throughout the Arctic. The clustering of historical AIS data in and around communities kind of can tell you a lot about anchorage locations, all these things that could feed into potentially coastal risk management, discussions or research in and around these communities, or ensuring that anchoring is happening in safe regions, or maybe less environmentally sensitive regions. It could be used for many different things. And then the use of historical AIS data to characterize polar class ship speeds and varying ice regimes is a very useful application of AIS data. There's not a lot of ships operating in the north. There's not a lot of knowns when it comes to ship speeds and varying ice regimes, because it is very complex to associate the local ice conditions with, AIS message reports. It takes a lot of knowledge of the ice, takes a lot of data. And kind of that's where we're really focused on is for every AIS report in the Arctic, trying to associate that with the best ice assessments of the ice conditions at the time that AIS message was reported. And then keeping track of the vessel speeds that we've observed, so we can start to produce statistical characterizations of vessel speeds in different ice regimes to feed all kinds of different quantitative analysis. And I think that's it. Obviously, this is not really a project that's run to completion. This is just a kind of a snapshot of some of the work we're doing and still writing up and still researching at Dalhousie and our group in the industrial engineering department. And that's it. Over.
Thank you so much, Mark. That was a really fascinating snapshot into the work that you're doing. And I can see a lot of implications for better knowledge, better data for navigation in the Arctic, to be safer and have more information about what the ice is doing and the implications that it has on a transit. So I think this will be really interesting to see how this continues to evolve. And I was wondering, I'll start off the questions with, have you incorporated any of the data that you've got of where ships are operating near communities into the low impact corridors work that's been ongoing for the last few years?
No.
I think
no, I've had no involvement or awareness of that activity.
Okay, yeah, I think that could be a really interesting to add to the understanding of what ships are doing near communities, and especially as we're starting to see some investment in infrastructure in Arctic communities, that knowing where ships are currently operating and how they're operating would be really useful to create more informed decisions. If anybody has questions for Mark, please feel free to put your hand up and ask a question, or you can put it in the chat and I can read it out for you. I note that Mark, your supervisor, Ron Pelot, is here with us as well. And Ron is the one of the co-leads of the Canadian Marine Shipping Risk Forum, along with myself. So we have representation from Dalhousie as well today. More representation from Dalhousie. So we also had Leah here too. So I've got a question here from JD Leahy from Washington Ecology. And are ships currently using any rules of thumb for estimating these times, speeds?
Yes and no, I'm sure they are. We have talked a lot with FedNav. They've been probably the most open about how they plan and conduct their operations. The reality is they say they don't do a lot of operational planning. They don't bother, I guess, is, they get there when they get there. They believe that Arctic navigation is more, something that happens at the tactical level. They may say we're going to try and get there in 5 days, but they don't try to get down to the level of, decimal hours kind of thing that we're trying to do here. So they have rules of thumb. They know different times a year how long it would take for them to get to the ports that they usually go to, but that's more based on experience. I don't think they try to adjust those transit times based on tactical ice analysis or anything, at least not that they shared. Over.
Thanks, Mark. So there's a question from Nadia Menard, who's asking about the low impact corridors initiative that I just mentioned. So I'll just read out that it is the Low Impact Shipping Corridors is a Government of Canada-led initiative with the goal of developing low impact marine transportation corridors in the Arctic Ocean to encourage marine shipping and transportation traffic to use routes that pose less risk and minimize the impacts on communities and the environment. And Clear Seas has been involved in some of the research by supporting work out of the University of Ottawa with the lead researcher, Dr. Jackie Dawson. And we've got some information on our website, clearseas.org, about that project. And I will also put a link to an article into the chat that explains some of the work that's been done there. So I will just share that, and you can can take a look at the description of the work that was done to understand the impacts of shipping activity on communities and the environment in the Arctic, and start to identify ways to mitigate those impacts through working with communities to understand the impacts of ice breaking on migration routes and ship noise on marine mammals, and the impact that that has for subsistence harvesting and many other impacts of that nature. Are there any other questions for Mark, or also if you had questions for Norma or Andrea? Unfortunately, Leia's had to go, but if people do have questions about Leia's presentation on ghost vessels, or not ghost vessel, ghost fishing equipment, I'd be happy to relay those questions to her, and she can get in touch with you directly. So any and all questions, or if anybody has their own research that they'd like to briefly share, we still have a few minutes before we need to wrap up today. Norma, I wanted to ask you a question about other possible implications for using the B+ type AIS transponder. Do you see that as something that would be useful for fishing vessels to help with understanding their activities and safety? Because I know that safety for small vessels is an area of concern.
Yeah, I think it's a technology that it will be useful for vessels that are not maybe required to carry AIS. And vessels that are operating in areas with poor coverage of terrestrial AIS. Even in our study on the west coast of Vancouver Island, there are a couple of receivers from Coast Guard that the coverage is pretty good, but when you start getting into the islands and around some of the more narrow passages and whatnot, we noticed that there was some spots where it was a bit weak, the signal, or there was no signal. So if you have then to supplement, you can have satellite AIS data to supplement that. That's great, but it only really seems to work if the transponders are B+. With B alone, it was not working very well. So if you're a small vessel and you work in sort of remote areas where the terrestrial is not very good, then the B+ is really the way to go if you want that coverage.
Yeah, that's great to know, because yeah, if you think you're going to be safe by installing a B transponder and then you go outside the reach of terrestrial and you're not getting any signals. So
exactly.
Good,
Yeah.
Good to know. And you said it was a little bit more expensive to have the B+, but
I think so, but I think it's maybe $200, $300 more expensive, but
not wildly so. Not as much as an A class.
It's not more than $1,000 like they are for the A class.
Well, I think that's great. Maybe we'll see more coverage for smaller vessels and have a better picture of what all of the different types of marine traffic are doing. I think that's going to be really interesting. Mark, I wanted to ask you about, with your presentation, when do you anticipate being able to wrap up the research that you're doing? What's your timeline? And is the goal to be able to share this this sort of transit time forecasting with ship operators so that they can make better estimates for how long it's going to take them to get through a certain area based on the ice data that's known?
Did Ron put you up to that question?
No.
I am in my 9th year almost of my PhD.
But who's counting?
Yeah, that's right. Faculty of Graduate Studies is. Everything has to be done, I think, within the next year. I think the way we're going to release it is just, there'll be a couple, journal papers on sort of the methods we've developed. The ice risk assessment works pretty pretty widely published already, but we're not the only ones looking at applying some of these techniques to better understand navigational risks. The calculations of the the ice risk adjusted transit times, that's kind of where I think the more interesting work lies, and it requires a lot more analysis. Again, this AIS analysis is kind of critical to get those speed. It's only as good as the speed estimates you're using. So you can be great at calculating or determining the risks, but unless you know how those risks translate into slower ship speeds, you're really just kind of guessing. And that's where I'm trying to be as careful as I possibly can, and trying to use the best data that I possibly can, and focusing on the best ships that I think are the safest ones, so that the observations represent kind of the highest quality result. But yeah, it'll just be published in in the literature, I guess. And I'm not envisioning a tool or a widget or some piece of software. It's really just kind of, here's the method, the method, how you produce them, the algorithms that you would use to produce these, and then some assessments of the quality of the estimates. But yeah, I'm not envisioning a tool, or I didn't get the memo either. I don't have a story map, but I'm a QGIS user too, so they don't really have such good tools like ArcGIS does, but yeah.
Now story maps, they're all the rage.
I know, I'm missing it. I remember I have been exposed to them before. Never resonated with me though, but they were great. I can see the power of using those tools to communicate geospatial data.
For your dissertation.
That's right.
Story map.
Yeah, that's right.
My recommendation. Well, I'm not seeing any other questions, so I think we'll wrap it up here. And if any questions do come up after the fact, feel free to reach out to me. My email address is megan.matheson@clearseas.org, and you can find me on the Clear Seas website. Or any of our presenters today. We will be sending out the recording and the presentation slides, or rather a link to them, to all of the people who've registered. So if you had to miss any aspect of this, you can catch up later. And I want to thank everyone so much for participating today. It's been great to learn about this new research. We will be having an additional, our next AIS webinar segment will be coming up in the early fall, and that will be focused on, we're going to be looking into the EMSA program, the Enhanced Marine Situational Awareness program that the Government of Canada has put in place with a number of different Indigenous communities around Canada. And we will hopefully be hearing from a community or one or two communities how they have been using AIS data to increase their understanding. So thank you so much for joining us today, and have a great rest of your day.